So good day guys, welcome to today's lesson. In today's lesson we are going to design the pad base, and let me show you what where we are going to do that in. That will be in the base. So let's go to plan and let's go to this level, foundation level. Okay. Now so you can see we have our foundations at this point. So what we need to do is let's see our reaction, and to see your reaction it is this: display support or spring reaction. So select it and let's choose what the maximum service load we need to do it to get our sizing. Okay, so you can't be selecting it one by one, because for example if I select UDCON S1 and I select it and I click apply, you can see I have a value here at this point of 3434. But if I change it to UDCON 2, it will change. Then I will have 4061. Then if I change to another UDCON, another load combination, it just continue giving me different values. So how do I know the most critical amongst all of them? How do I know? So the only way I can know is to use my envelope which we've created. So remember, for sizing the footing, to get the size of your footing, you use service envelope. But to get the ultimate, that's the thickness of your footing and the reinforcement you need, you use the ultimate envelope. So let's select the service envelope. So once you select the service envelope, we have max and min. So you can just select max and you click OK. So once you do that, it will select the maximum, the worst case scenario for all these. Okay, so you selected the service envelope. You can also select min. Okay, so to give you another value for it, so you can give it the most critical value for it. But in this case, let's use we can use absolute max and select it. So let's use absolute max now. So what we have is our envelope. Now this is a shear wall, you can see, so it has been supported at this tip and at this tip, but don't forget it is going to be per meter run, because if you look at it this way, sorry, let me look at it this way, let me rotate it, so you can see the value here. It is per meter run, FZ, 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 and FZ per meter run. So we can see what you have. So just you need to know what you are doing. Whatever you are doing is going to be per meter run for the shear walls, but for the column is just going to be kilonewton, a point load. So let's go back to our plan. That's the base. Okay, so now let's see our service load, the critical service. Now the UDCON we were using before was ultimate, but this is service. So for example, we have a value of 3257.8. So I'll come here. Now my soil allowable bearing capacity is 600 kilopascal, that's 600 kilonewton per meter square. Then this is 3257.8, 57.8. Then press enter. So the minimum I need at this point, is a rough estimate. The minimum I need at this point is 5.4. Let me bring this out. Okay, so I just created this Excel sheet for us to get the basic sizing. So you can see for that column I need a 2.3 by 2.3 meter footing. Then my thickness can be, this is a trial thickness. So most trial thickness is always the length over 6. That's just a way of getting initial estimate. But we know thickness of footing is a function of bending, flexure, and punching. So sorry, bending, punching, and one-way shear. So punching is a two-way shear. So we'll try this. If this fails punching, we'll have to increase our thickness. So we've seen this one. Let's try another big footing again. Let's see the bigger size. We have a value of 5,000. Okay, 5,396. So 5,396. 5,396. Let me say 7. Okay. So we need a footing size of 3 meter by 3 meter and our trial thickness of 500. So let's run our footing and let's see what we'll get if the pressure is going to be okay. So let's just, to simplify this, we'll make all our footings for our column going to be 3 meters by 3 meters. So what we need to do first is to unlock it. Okay, so once you unlock it, let's go to define, section properties, slab section, and add a copy of this property. So let's say we are doing pad base, let's say 750. Let's assume we are using 750 thickness, and we are using this for our pad footing, this grade for our pad footing. Then the thickness of my pad footing is going to be 750, and the type is going to be footing. Okay, so once you select it, you click OK and click OK. Now, next thing I need to do now is I'm going to highlight this base node and I'm going to delete it. So I'll go to assign joints and I'm going to no support. This is it. So click OK. Now let me explain what it is. You know, the building is going to be on the soil, and the soil is like a spring. The soil has its own stiffness. So if, for example, you say it is fully fixed or fully pinned, and we know our soil is in between fixed and pinned, so you won't get the real behavior of the structure because we've assumed it as either fully fixed or fully pinned. That means no displacement, no rotation, nothing. But in this case, because of the soil, it's still going to compress. There will be a reduction in, there will be consolidate, compaction and everything. There will be water seepage, reduction in pore water pressure, so which will lead to settlement. So that is why we are going to be modeling the soil interaction. So what I'll do is I'll come here for my slab. Okay, sorry, select this, choose the property for my footing to pad base 750. What is my x dimension? We said 3 meters, so that's 3000, and this is also 3000. Okay, so I'm going to place one here, place another pad base, place another pad base. Now this is almost close, so we can take it as combined, but in this case I will ignore it, so, or I will put it there so that we can see the effect. Okay, put here, put here, put here, put here. So in the middle I'll put it there. Okay, so let me just, also here I'll put, yeah, I'll just get this. Now let me just know for my pad base for this middle point, what I can do is I can just add maybe 6,000 by 300. Okay, so let me pick the middle point. If I can't get the middle point, so I can select it. So let me just delete, select this, and delete it. So we have this here. Let me just delete this one here. So I'll delete it, and I'll just copy it. Okay, so let's go to copy. I'll move it from the center line from here to here, apply, select this also, another 50 point from here to here, apply. So this one is overlapping, then select this one again from here to here, apply, and last but not the least, select it from here to this point, you also apply it. Okay, so this one that are overlapping, you can either join it, merge it together. So select it, select this. Let me untick all this. Okay, so select these two, then you can come here and merge shell. Okay, let's see if it will merge. It will merge because they are overlapping. So what I can just do is delete this. Okay, and draw another one there. Okay, merge. So then make this one to 6 meters, or I'll make it 6.5, 6,500. Okay, so I will select this. Let me pick a middle point. So before I can pick a middle point, it will be difficult. So I'll just draw a beam here. I can just pick any beam here and split into two. Okay, insert, sorry. I'll come here and split the beam into two. Select one here, then I can draw a beam here from here to here like this. Okay, then split this one into two. Okay, split into two. So I want to do a pad base of 6 meter by 6 meter, or let's say 6.5 by 6.5, or yes, okay, this is okay for me. I'll just select it, paste it here, so you can see what I have. But I think this is too big, so I'll change it to maybe 6. Let me delete it. I'll make it 4 meters. Okay, so go back here and make the Y 4 meters. Okay, so this is what I have. Okay, so I can select this, delete, select this also and delete. So I think I'm done with my pad bases. So highlight this again, go to assign, make sure there are no restraint assigned to any of them. So we are done with that. Now the next thing we need to do is we are going to assign the support for the pad, that is the soil. So once you come here now, go to define section property, sorry, spring property, and you will see we have different types of spring. Okay, you can use soil profile, you can use isolated column footings, but this is easier for us. So let's start with area spring. So when you see area, just know we are talking about plates and slab. When you see lines, we are talking about beams, and when you see points, we are talking about just the column. So let's start with area spring now. Let's add a new property and let's see 600 kPa. That's the name. Now we need to get this direction, we need to get it. Okay, but first of all we need to be in compression because it's going to compress the soil. We don't think it's pushing the soil up, so compression. So let's put it as compression, and let's get our value of the spring constant or unit area. So the unit is what? Kilonewton per millimeter raised to power 3. That is the stiffness. So the way we can get it is to get our allowable bearing capacity times the factor of safety. So let's say our factor of safety is 2.5, and our maximum settlement should not exceed 50 millimeter. That's what I'm choosing. You can decide to choose 25 millimeter, you can decide to choose 75 millimeters, you can even decide to choose 10 millimeters, or even a kilometer. If you wanted to settle more than a kilometer, you are the engineer, you determine what you want. So I have this, which is equals to this asterisk, my safe factor of safety is 2.5, then divided by, I know I'm using 50 millimeters, so 50 divided by 1000 is 0.05. So my stiffness is 30,000. Okay, that is my stiffness. I have it. Or you can come here and use the same calculator. So what I have is 600 asterisk 2.5 divided by 0.05, then enter. So this is what I have. So I can just copy this and click OK. Now we have this. Next thing I need to do is define my point spring too, because the column is there. So I'll just define a point spring, add new property, maybe 600 kPa. Okay, so I'll just select it, paste it here, paste it here, and paste it here. Okay, so because translation X, Y, Z, I don't want it to translate around. This is what is holding it. So if this one is strong enough, it will not translate so much. Okay, so select it, click OK. Now what I'm going to do is I'm going to select all the nodes at this point. Select these nodes, select, 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 select this. That's where the columns are. Okay, select it. Okay, so we now go to assign joint spring. Sorry, assign joint spring, and this is the one we just created. Apply, click OK. Now you can see the spring. Now the next thing I want to do is to assign it to the plate. Now so once I select this, I'll go to assign, then go to shell, and I'll go to shell spring. So look at area spring. Okay, so select this and click OK. So you can see the area spring has been assigned 600 kp, 600 kp. So what we'll do is to run our analysis, then we will now check it fully if most of the sections for our footings we gave are sufficient. So in the next video we'll continue that.